Okay, so today let's take a look at a question on vectors. Generally for vectors, right, in H2 Math is being divided into two categories. For the first category is talking about like general vectors, studying on all the properties of dot product and cross product. For the second category is dealing with those questions on 3D coordinate geometry, like looking at lines and planes, how they interact between each other in a 3D space. So for this particular video, we'll be taking a look at the question on just on the general vectors. So take a look at this question. It says that referring to the origin O, the points A, B, X are such that OA equal to A, OB equal to B, OX equal to A plus 3B. And you are also given the magnitude of modulus of A, modulus of B, and OX, and so on. So just write down this information here. So OA will be equal to A, OB equal to B, OX equal to A plus 3B, modulus of A equal to 2, modulus of B equal to root 5, and modulus of OX equal to square root 73. So for part A of the question, say by considering the scalar product of OX with itself, or otherwise find the value of A dot B. So what does it mean by scalar dot product of itself? So for scalar dot product, we have this formula, which is A dot B equal to mod A, mod B, cosine theta. So if you will be using a vector dot by itself, right, in this case, you will actually be replacing all the B with A. So you will be A dot with A by itself. So you will left with modulus of A, cosine 0. Right? Because when you are using two vector dot by itself, the angle between them is just 0. So simplifying this, we'll just get A dot A equal to mod A square. And cos 0 is 1. So this is what we have left. So this is actually, I think this is a pretty powerful formula, because actually what you're doing here, you are like kind of linking a vector with a magnitude. So if you have two vectors, when you dot them together, you get a magnitude. And sometimes, right, some questions require you to work from a magnitude into a vector. I think later on we'll be using this from the right hand side to the left hand side to look at one of the questions we'll be doing later on. Right, so anyway, so this question wants us to considering the scalar product of OX with itself, so we will have OX dot with itself, and this actually will be equal to A plus 3B, because OX is equal to A plus 3B dot with A plus 3B. Right, so for the left hand side, dot by itself, I will end up with modulus of OX square. And this we can make use of the distributive law. So you will just be A dot A plus 3A dot B plus 3A dot B plus 9B dot B. So this will end up with modulus of A square according to this again. This one we can combine together, we get 6A dot B. This one we get 9 modulus of B square. Right, so we can just plug in all the values given to us. So for like this is just replaced with square root 73 square. This one will just be 2 square, 6A dot B. This one will just be root 5 square. Alright, so this will be 73, this is 4, this is 6A dot B. This one will just be 5, 5 times 9 is 45. Right, so simplifying everything, we should be able to get A dot B equal to 4. So this will be my answer for the first part A of this question. So now moving on, part B say find the area of the triangle of OAX. Let me just erase this part away first. So area of OAX. So we have a formula to find the area of the triangle OAX. is given by OA cross with OX. Right, so for this formula for area of a triangle, in fact, we can just use any two sides we want. You can actually just use OA cross with AX. It doesn't matter. But I think usually if you use the vector starting from the origin, it's slightly easier. Right, so in this case, OA will just replace with A, and OX is given by this. So you'll be A plus 3B. Okay, then we will just use distributive law to cross again. So this cross this, I'll get A cross A. This one, I'll get plus 3A cross B. Right, take note, right, when you are doing crossing, right, the order in which you cross matters. Right, A cross B is not the same as B cross A. Right, but for dotting, it's the same. A dot B is the same as B dot A. So you have to be particularly careful with this. So this one, I cannot write it as B cross A. I have to write it as A cross B. Okay, when we are crossing two vectors together, which is of the same direction, it will end up to be 0. So here, I will left with 3 over 2 modulus of A cross B. Okay, and actually, there's a formula for A cross B also. So for the formula for A cross B is given by modulus of A, modulus of B, sine theta. All right. By right, crossing right, there's a n cap here to represent a vector that is perpendicular to both A and B. But because of the modulus here, modulus of like the normal unit vector, you will end up to be 1. So I know to write it here. So looking at what the information we have this, so we can sub in. But unfortunately, we do not have the sine theta. Alright, but I think not a big issue because we can determine what is the sine theta from this formula here. So this is again the formula for the dot product. So we have found out that previously this value will give me a 4 and this one will just be a 2. Mod B will be square root 5. We can find out what is cos theta first. So cos theta will give me 2 over root 5. And we can make use of the triangle, the trigonometry triangle. So this one will just represent adjacent over hypotenuse. So 2 root 5. Using Pythagoras, which should give me a 1 here. And from here, we can actually find out what is my sine theta. So tan theta will just be opposite over hypotenuse, 1 over root 5. Right, so having all these values now, we can just sub inside. So 3 over 2, modulus of A is 2, modulus of B is root 5, and sine theta is 1 over root 5. Simplifying, it will give me an answer of 3. Okay, let's move on to the last part of the question. So now you are given a variable point B and not necessarily coplanar with ABX, meaning that ABX might not be able to lie on the same plane. And this position vector, the point V has a position vector of V, and it's given by this weird expression here. And you're supposed to describe geometrically the set of all possible positions of the point V. All right. Usually, I will say that when they ask you to describe the points geometrically, right, chances are pretty high that it might be either an equation of a line or equation of a plane. Right, so let me just start off with this expression here first. Modulus of V minus A equal to modulus of V minus B. Alright, so let's recall just now what we have discussed. We know that A dot A equal to mod A square. Alright, so I think, right, if I want to convert into a vector form, right, of an equation, I think perhaps I can try to attempt to work from right hand side to left hand side, which use the magnitude to convert into a vector. So in this case, right, the first step, maybe I can try to square both sides first. So by squaring both sides, I can see I can convert from the right hand side to the left hand side. by treating this like a A. Treating this like a A also. So when I reverse it from right hand side to left hand side, I'll get V dot V minus A dot with V minus A, and right hand side will just be V minus B dot with V minus B. Alright, then now I will try to expand out. So I got V dot V minus A dot V. Maybe I can just write a 2 here because it's the same. So plus A dot A. Similarly, for the right hand side, I got V dot V minus 2 B dot V plus B dot B. Alright, these two terms are similar, so it can be cancelled away. Okay, so now maybe I can just shift this over to the right hand side, this to the left hand side. And this I know will give me modulus of A squared, and this will give me modulus of B squared. So I will land up with mod A squared. This one I shift it over, I get minus mod B squared. The right hand side I will get 2A dot V minus 2B dot V. Okay, so here I can divide throughout by 2. Let me just rewrite this to shift it on the left hand side, this on the right hand side. So I will get V dot A minus B equal to mod A square minus mod B square over 2. Alright, if you can now recognize, right, actually this is an equation of a plane. Comparing with the general form of our plane is R dot N equal like P. So the V is like the R. This A minus B is like the normal. This one will just be P. So from here I can just do my conclusion already. So therefore, V are points that lies on a plane with equation of this. So it's equal to V dot A minus B equal to mod A square minus mod B square over 2 with normal of A minus